GATE 2019 Civil Engineering Set 1 Question 19. For a given loading on a rectangular plain concrete beam with overall depth of 500 mm, the compressive strain and tensile strain developed at the extreme fibers are of the same magnitude of 2.5 into 10 to the power minus 4. The curvature in the beam cross section needs to be found in meter inverse rounded off to 3 decimal places. The relevant NPTEL reference has been cited. One needs to know about the simple bending theory to solve this problem. This theory relates the moment acting on a beam divided by the inertia with the stress on the beam divided by the distance from the center to the extreme fiber equal to the modulus of elasticity divided by the radius of curvature. So in this case, if we are given a beam which has a depth d and moment is acting on the beam, so a strain profile will be produced which is somewhat like this, where this will be the tensile stress and this will be our compressive stress. This is taken in negative sign and the tensile part is taken in positive sign. Here y represents the distance from the center to the extreme fiber of the beam. Moment is the external load effect that is acting on the beam. I is the moment of inertia, sigma is the stress, y is the distance as shown in the figure, E is the modulus of elasticity, and R is the radius of curvature of the beam, because due to the load the beam bends in the following shape and it will form a circle whose radius will be R. So for rectangular beams the radius of curvature is R and the curvature in general is given as 1 over R. In this case we have been given the tensile stress which is equal to the compressive stress as 2.5 10 to the power minus 4. The depth of the beam is given as 500 millimeter. We need to find the curvature of the beam, that would be 1 by R. So using the theory of simple bending, that is m by I equals sigma by y equals E by R. In this case we are not aware about m and I, so we cannot use this part of the equation. So we need to solve only using this part of the equation to find our answer as the curvature. So sigma by y will be nothing but half of the depth. This is equal to E over R. So what we need is the curvature. So curvature is 1 by R. This can be written as sigma over E into 1 by D by 2. Sigma over E is stress by elasticity modulus is strain. So this will be 2.5 into 10 to the power minus 4 divided by half of the depth, that is 250 millimeters. This needs to be converted into SI units by operating it with 10 to the power minus 3. This would give the answer as 0.001, which is our curvature in units of meter inverse. So a rectangular plain concrete beam whose tensile strain and compressive strain magnitude was given along with the overall depth of the beam. The curvature in the beam was found out as 0.001. The relevant NPTEL reference has been cited.